Assume recording. Okay, so ano ba tong Green's function na to? Kuwari may differential equation tayo na, let's say, d squared. Okay, dx squared. Tapos we have some u, function of x, plus sabihin natin x squared, function of u of x. Then this is all equal to some function of, again, another function of x, which is f. Okay, so ang problema natin, malaking problema to, di ba? Nakikita niyo. Malaking problema rin, hindi natin alam paano i-solve. Okay? So si Green, kung sino man si Green, nagawa siya ng solution para ma-solve mo, in general, kung paano yung mga bagay na ganito. Okay? So sasabihin natin ngayon na meron tayong tinatawag na linear operator. Curly L. Okay? Fancy L. De-define natin siya as kung ano man yung nangyayaring operation dito on your left-hand side. Okay? So plus x squared. Okay? So this is an example. No? Si L, pwede magbago yan. Okay? Depende sa situation or given na problema sa'yo. Then we can just rewrite this guy, this whole thing as L of u of x must be equal to f of x. Okay? Okay. Okay, so the problem is now shorter, pero same difficulty pa rin. Yan, pa rin yung problem mo, i-rewrite lang natin as sum operator. So ina-apply mo na lang ngayon yung something to your u, and that should transform into x, into f of x. Okay? Okay, sabi ni Green, ang sinabi ni Green, okay, I think I can write some function g, okay, g, which is function of some variable s. Okay, so si x ay yung sa problem natin. Okay, then si s ay some random variable. Okay, then I can write this as a Dirac delta. Sabi ni Green ito daw yung pwede kong solve na lang itong problema ko ito. Itong problem na to to solve for this whole guy. Okay, then sabi ni Green, pwede pa ako mag-isip ng further solution. So sabihin ko na yung solution ko, si u of x yung hinahanap ko. Okay, in this problem, no? In this problem, si u yung hinahanap mo. Si f of x given to. Okay. Pag dumali buhay mo, 0 lang to. Okay. Minsan hindi kasi 0, mahirap. So in general, f of x lang siya. So si u yung kailangan mo. Okay, si u of x, sabi ng Green, pwede ko siyang isulat as some integral. Okay. From a to b of g of x s f of s ds. Okay? So si s again, dummy variable lang yan. Pwedeng kahit anong variable yan. Then si a at b will be depending on the boundary conditions of your problem. Okay? So how does this all come together? Okay? Now, try natin i-apply yung operator, linear operator mo kay u. Okay? So si linear operator, i-apply mo ngayon kay u. Siyempre, ma-apply din siya sa right-hand side mo. Okay? So, may integral ka a, b, g, x, s, f of s, ds. Okay, saan tatagos si L? Sa mga functions of x lang. Okay? So, si g lang yung apektado. Si f of s, siya tatablan. So, now I can write a to b integral ng LG, x of s, function of s, ds. Okay? And then, I know, sinupost natin kanina itong si LG, di ba? Alam natin si LG na siya ay si Dirac delta function x minus x. Okay? Dirac delta function of x minus s, f of s ds. And we know this. Okay? We know this. We know this guy. As long as a to b, yung s natin, yung a to b na bounds natin, pasok si value ng x. Then, we know that this is just f of x. Okay? And the left-hand side, rewrite lang natin, L of u of x. And this is our original problem. Okay? So, ayan siya, L of u of x. Tapos, equal yan sa f of x. Okay? So, ang galing ni Green, no? Pwede pala yan ganun. Okay, so imbis na isolve mo yung problem na ito, pwede mo nang gawin lang yung problem na ito. Okay? So, syempre, kailangan natin ng example. Di natin gumagets kung wala tayong example. Dahil sa example tayo matututo talaga ng mga bagay-bagay. Okay? So, let's start with an example. Wait lang, ulit ko lang notes ko. Okay, suppose na yung solve natin, green na tayo para example. D squared y of x dx squared. Okay. Negative f of x. Okay, Laplace transform po ba yung L? No. Yung L dito ay some linear operator. Okay? Yung linear operator, define lang natin siya as some random operator. Okay? Para lang masulat natin yung problem natin as simple as this. Okay? Okay. So try natin with an example para hindi tayo maguluhan. So hindi siya Laplace transform, no? Hindi siya Laplace transform. Okay. So let's try this guy. Okay. The second derivative of y must be equal to some negative function of f of x. So this is very familiar, no? Pwede natin isipin to as d squared dx squared some function of potential over negative rho of x over epsilon naught, di ba? So yung f of x mo will be rho of x over epsilon naught. So very familiar to. So sulat mo lang natin siya as random arbitrary functions y and f. Okay? Okay, what's our linear operator? Let's write it down. Yung linear operator mo, in this case, would be L, go with B, defined as d squared dx squared. Okay, now I can rewrite my whole thing as L, okay, y of x, and that would be equal to negative of f of x. All right, okay. Now I can suppose my my solution could be written as this: the integral from a to b, some g of x prime. Okay, and then f of x prime dx prime. Okay. Okay. Then I put negative. Lagyan ko negative, no, para makuha ko itong negative ano dito. Okay. Okay. So I have it na kapag sinulat ko na yung L of G ko, x prime, that should be equal to some Dirac delta x minus x prime. Okay. Then, syempre, dapat pag pinagsama ko na sila, dapat makapalabas ko yung gusto natin. So, I apply my operator, L, to my y. Then, this should be negative a to b. Si L papasok kay G. Okay? Kasi si L ay function of x and si G ay function ng x and x prime. Then si f of x prime hindi siya tatablan. Okay? Kasi x prime siya. Okay, so lumipat tayo sa ano, no? So, lumipat tayo sa kanina S2, di ba? Gusto ko x prime na lang para marerelate naman natin sa marerelate natin siya sa ano natin, sa notation natin. Di? So x prime kasi di ba yung notation natin for the places of the charges. Okay, so I now have I know my LG, which is just Dirac delta of x minus x prime. Then dx, f pala muna. X prime, dx prime. Then this is just negative of f of x. Okay, which is just our problem. Okay, so tama yung setup ko ngayon. Nag-set up pa lang tayo ng equations na nag-set up ako na kailangan kong i-solve to. Kailangan natin i-solve itong sulatan natin ng blue. Kailangan natin i-solve to. And then suppose that my solution is this guy. Okay. So nagkaroon different siya kanina kasi may negative tayo. Okay. Okay. So accounted for naman siya. Kung bakit ako naglagay ng negative. Okay, gets ba kung bakit? Okay. Okay, now we can solve this, no? Kung wala tayong initial conditions. So let's say na initial conditions natin will be y is equal to y of 0 is 0 and then y of 1 is equal to 0. Okay? Okay, so wait lang, ayos ba yung video ko? Kasi hindi ko alam kung mahina internet ko eh. So let me know. Okay naman ba? Dire-diretso ba ako magsalita o nagpuputol ba? Thumbs up kung okay naman. Okay, thank you. I'm just a poor guy with no good internet connection. Okay, so continuing. Saan na tayo? Ang kailangan na natin i-solve is si LG. Okay? Sulat natin. So our problem is LG x prime. Okay? This must be equal to x minus x prime ng Dirac delta. Okay. What happens to the right-hand side if my kung yung mga variables na to ay hindi equal? Alexandra, what happens?
Paulit po, nag-choppy po kayo sa akin.
Okay, sorry. What happens on the right-hand side kapag hindi equals x at x prime?
Sir, sorry, wala po akong...
Okay, tulungan nyo siya. Kazumi, what happens to the right-hand side?
Hindi ko pa po sure kung ano mangyayari.
Okay, magtulungan pa rin tayo. Jello.
Magiging 0 po, sir.
Okay, very good, very good. Okay, kasi di ba, tandaan natin si Dirac delta. 0 yan pag hindi equal si x at x prime. Okay? Tandaan natin si definition ng x prime is just 0 when x not equal to x prime. Okay? And this will only have a value if the Dirac delta integrated. Okay, pag pumasok siya sa A at B, si A, basta sa integral sa interval na A at B, nag-equal si x at x prime, saka lang siya magiging 1. Okay? Okay? So now, what do I do? Sulat ko ulit si L as derivative d squared dx squared g of x prime. Okay? And then my right-hand side will be the Dirac delta of x minus x prime. Okay? Now, what I want to do is, gusto natin mapasok sa integral tong si Dirac delta, di ba? Kasi we have this, napakadali gamitin ito. Okay. Luckily, we can do that. No? We can integrate this whole thing with respect to x. So pag in-integrate ko to with respect to x, matatanggal lang isang derivative na, which is nice. g of x minus x prime. Okay. And then I have integral, sorry. Oops, nawawala yung dx. Then this is the Dirac delta. X prime dx. Okay? So dx yung integral natin kasi para matanggal tong dx dito. Matanggal yung isa. Okay? So we have dx. Okay, isa na lang. G of x minus x prime. Now, what I want to do is kailangan pasok sa integral, pasok sa interval sa x prime, no? So lagyan natin ng bounds which is x prime. X prime, pero dagdagan ko ng onte. Okay? Dagdagan mo ng onte. Si epsilon ay some small constant. Okay? So we have to evaluate this as half x prime plus epsilon x prime minus epsilon. Okay? And then your right-hand side would be simple, no? Kasi si x, pasok na siya sa range ni x prime. So this is just equal to 1. Okay. But we can still solve this kasi hindi naman natin alam si g. Okay? So panic tayo muna. Balik tayo dito sa simula. Okay? Sabi natin, kapag hindi equal sa x at x prime, my problem transforms into d squared dx squared g of x plus x minus x comma x prime, and this is just 0 when x not equal to x prime. Okay? And I know this. Alam natin to. This is the Laplace equation, no? Sinolve natin to last time na, di ba, may d squared ka, tapos d squared, y squared, v 0. Okay? So this time, madali lang kasi isang variable lang yung ano natin. So we can now write g of x minus x, x prime lang pala. Sorry. Okay. As two equations, I can write down this guy, y1, x, h1, x prime. So nag-separate lang ako ng variables. So sinabi ko na the solution for g can be this guy. So may function ka ng x multiplied by a function of x prime. Si h, di ko alam yan. Si y must be related to yung y natin. Okay? So must be related to your original problem, which is y. Okay? Then, this is for x that is less than x prime. Okay? Pag tumawid siya sa Dirac delta, it must be different. No? So let's write down y2 of x. Then h2, okay, of x prime. That is for greater x prime. Okay? Kasi bakit tayo may dalawang equation? Kasi we're not sure na kapag this is above x prime, ito pa rin yung lalabas, di ba? Ito pa rin yung lalabas. And whenever this x is below x prime, ito pa rin yung lalabas. So dapat, pwede natin sabihin dapat na may dalawang solution. Okay? We can say that they are both equal. Okay? Kuha. Okay. Now, we don't know h. However, si Green sabi niya, g of x prime should be equal whenever pinagpalit mo si mga values. So, symmetric daw si G. Okay, so si Green's function ay symmetric. With that, masasabi natin na si h1 of x prime is just equal to some constant a multiplied by y2 x prime. Okay? Si h1 ay si h2 I mean, si h2 of x prime to be symmetric, dapat a1 prime. Okay? Okay, so we plug in that. So we have, so I can write g of x prime must be equal to those two equations. Let me write this down as g minus, and then g plus. So this is equal to kanina. So y1 times this guy. Okay? So magkakaroon ako ng a, y1. A is a constant na hanapin natin. X, then y2, x prime. Okay. And then for the second one, that is a, y2 of x times y1 of x prime. Fairly straightforward. Pinlog in ko lang yung mga h natin. And this, of course, will be whenever x is less than x prime, x greater than x prime. Okay? Okay. So far, so good. Okay, so for brevity, nilagay ko lang ito para madali ko siyang invoke mamaya. Okay? Okay. So we now have a general form of the Green's function G. Now we go back to our equation, and we know we can write G here as G prime of x prime. So yung prime dito, iba dito sa ano lang to. Ito ay derivative. Para lang madali buhay natin. Mahaba kasi sulat eh. Okay, that is equal to 1. Okay. Ulit daw sa general form ng G. Okay, bakit ganito yung form ng equation natin? Dahil naalala nyo sa separation of variables, di ba? Sa separation of variables, as long as yung right-hand side mo is 0, yung mga second derivatives mo, pwede mo siyang isulat as, di ba, ang function natin last time is bxy. Naalala nyo kung lesson? Tapos sinulat natin siya as x, capital X of x, capital Y of y. Okay? So in the same way, since alam naman natin whenever x is not equal to x prime, we can always do that. Okay? So ito yung nangyari. We have a function for x, the first variable, and x prime, the second variable. Okay? Kaya sila naging dalawa kasi meron tayo yung two conditions that will produce this guy. Okay? So, di ba, dito Dirac delta siya. So, whenever x is above x prime, you have this. And whenever x is less than x prime, you have this also. Okay? So, kaya dalawa equation natin. Now, hindi natin alam si h. Okay? Hindi rin natin alam si h2, h1. Hindi rin natin alam. Basta alam lang natin, this is a function of x prime. So, we write that down. Tapos, sinabi lang sa atin ni Green na dapat symmetric yung Green's function. So, pag binaliktad mo yung Binaliktad mo yung mga arguments niya, x and x prime, dapat same lang sila. Okay? So with that requirement, masabi natin that the only solution for this, for h, has to be this guy. Okay? Okay? Okay. So now we go back. So we have here this guy. So let's expand this. So in G mo, G of x, G prime, derivative ng G with respect to x has to be evaluated sa x plus joke. Lagyan natin equal para hindi nakakalito. Epsilon x prime. Okay? Bakit hindi si x prime? Kasi integral natin ay with respect to x. Si x yung gagalaw. Okay, minus G prime. In-evaluate lang natin itong yung mga x prime tsaka, oops, x prime dapat. X prime. X prime, x must be equal to x prime minus epsilon. And that must be equal to 1. Okay? Okay. Now, what do we do? Yung kailangan natin gawin is limit this guy. So we make epsilon very, very, very small. So limit as epsilon approaches 0. Kasi gusto natin malaman yung value at x prime lang. Okay? So G prime. Actually, apply ka na natin dito rekta. Madali lang naman. So we apply the limit as epsilon approaches 0. Okay, in-apply ko sa buo. So mawawala lang yung epsilon, no? Okay. So yung 1, di apektado yan. Ano mangyayari dyan? Okay, sir. Bakit parang may weird dito? Okay. Tingnan nyo, no? Magsi-zero lang ba to? Okay. Magsi-zero lang ba to? So titignan natin muna kung bago tayo pumunta dito. Titignan muna natin yung behavior nito. Okay? So yung una dito sa left term, makita natin that G here is above epsilon. Okay? So above x prime siya kasi may plus epsilon ka pa. Okay? And then this guy, yung G mo dito, yung G prime mo, is below x prime. So I can use my G here kasi alam ko na yung dalawang G dito will represent those that are below x prime and those that are above x prime. Okay? Okay, so I do that. So this is actually, dahil nakita natin, this is plus. So this is actually plus and this is actually minus. Okay? Okay? So kaya ako sinulat as G minus as G plus para mas madali natin makita. Okay, so above x prime, yung G plus, tama naman. Okay, above x prime to. Okay? So now, hindi to magsi-zero, no? We evaluate G prime plus. This is just the derivative of x. Ito. So sulat natin. Sulat natin dito. G prime x prime. Okay, so meron tayong G minus prime tsaka G plus prime. Sinulat ko lang dito para madali natin makita. So derivative lang with respect to x. Okay? So A y1 prime of x, y2, hindi tatablan ng derivative. Okay. And this is x less than x prime. The other guy, g plus. So, sinong tatablan ng derivative? Si y2 lang kasi siya lang yung with respect to x. Okay? And si y1, hindi tatablan. Kasi x prime siya. So, again, this is greater than x prime. Okay, I write a boundary para hindi tayo mahirapan. Okay. Okay, so we have these values of g prime. Okay, so let me write that down. Hirayin ko na to. So ano yung mina-minus natin? G plus tsaka G minus. Okay. G plus will be A y2 prime. A y2 prime of x. Now y1 of x prime. So this is evaluated at x prime, no? Okay, so we put that down. Tapos the other side will be minus this thing. So si y1 yung naka-derivative. y1 yung naka-derivative. Again, evaluated at x prime, so magiging x prime na siya. y2 of x, and all of this must be equal to 1. Okay? Okay. Now, ang gagawin natin is gagamitin na natin yung boundary conditions to solve for y. Okay? So, ano yung boundary conditions natin? Okay, this guy. So, y0 is equal to 0 and y1 is equal to 0. Okay? So, si y1 would actually be the lower bound. y1 is to the lower bound. And y2 is the upper bound. Okay? So, si y1 sabi, lower bound, ano ibig sabihin nun? So, y1 of x should satisfy this condition. y1 of 0 must be equal to y of 0. That is 0. Okay? So, ito ay mula sa given natin. Okay? Ayun yung ibig sabihin ng lower bound. Then, y2 will be the upper bound. So, y2, satisfy niya dapat yung condition na isa, which is y. Okay? So, nililinyahan ko ng pula kasi given yun. 0. Okay? Now, we can find solution for for y1 as the solution for y1 can be written as y1 of x can be equal to x, so that I can write y1 of 0 as 0. Okay? Then y2 of x, I can write that down as I can write this guy as 1 minus x. Para pag nilagay ko si 1, that would give me 0. Satisfies the whole thing. Okay? Now, I can get my derivatives. Kasi ayun yung kailangan ko rin. The derivative with respect to x, that is just 1. And derivative with respect here is with respect to x din, syempre, y2 prime. That gives me 0 yung ano, so negative 1. Negative 1. Okay. Now we have all what we need. So we write this whole thing down. We write this whole thing down. Okay. Sulat muna natin a y2 prime of x prime. X prime to. y1 y1 of x prime minus a y1, oops, sorry, y1 prime of x prime y2 of x y2 of x tama, must be equal to 1. Tama. Sir, yung pagpili po ng solution for y1, x, y2, x are I arbitrary. You can say na arbitrary, pero it comes with experience na kung ano yung pipiliin niyo. So by practice siya nakukuha. Okay? But it is safe to get yung simplest na maiisip niyo. Okay? Okay? Minsan kasi, okay, kaya natin naisip na linear yung solution. Kasi second derivative ng g has to be 0. Okay? And kung hindi, pwede pala tayo, okay. So yung solution pala natin, quadratic, no? Kasi these are both, actually, linear lang pala, no? Linear lang. Okay, pwede mong, dito ka kasi magbabase. Okay, pwede kang kumuha ng linear at quadratic na solution para mag-vanish siya with respect to x. Okay? So, dapat yung pagiging arbitrary ng pagpili mo ay may rason. Kasi hindi, it satisfies din na y of x can be, sabihin natin y1 of x, sabihin natin ng color. Okay. y1 of x, let's say x raised to 6. Okay. That satisfies din, no? y1. 0. 0. Okay? Di ba make sense? Pero, dito pa lang, isipin mo na the derivative must vanish. The second, the function should vanish at the second derivative pa lang. Okay? So, hindi rin tayo kumuha ng solution na transcendental function kasi hindi nag-vanish yung solution nun. Okay? So, we go for the safest thing. Okay, so again, let's go back. Meron na tayong mga values ng y at y prime natin. So we plug things in. Okay, so factor out ko yung a. Then I have y2. What is y2 prime? y2 prime is... ito pala. y2 prime is negative 1. y2 prime is negative 1. y1 of x prime is y1 of x prime is x prime. Okay? Minus, pinactor out ko yung A, y1 of x prime pero nakaderivative, and that is just 1. 1. And then y2 is 1 minus x. Oy, nakalimutan tayo sulat. X prime dapat to. Okay? Nakalimutan ko lalagyan ng x prime. So this guy is 1 minus x prime. And that is all equal to 1. Let's simplify things. So this is just a negative x prime. Yes. Negative x prime minus 1. And then negative, negative, positive. This cancels out. And you're left with a equal to negative 1. Okay. So all that hassle, negative 1 lang pala lalabas. Okay. Okay. Now you have your Green's function. The Green's function is given by okay, this guy. So multiply mo lang yung y1, y2. Okay. Plus y2, y1. Okay. Going back. So a, this is yung a mo ay negative 1, y1 of x. y1 of x is just x. And then y2 mo is 1 minus x prime. Okay? Then si a ulit. Tapos si y2 na yung x mo ngayon. Tapos si y1 yung x prime. Okay? And this is for x greater than x prime. And then this guy is x less than x prime. Okay? So anong sense ngayon? How does this solve our problem? So this solves our problem kasi pwede mo nang i-plug in si G. Pwede mo i-plug in si G sa value ng y mo. So ito yung solution natin. Let's try this. So y must be equal to the derivative. Y must be equal to, may negative yun, di ba? 0 to 1. Okay, gets kung 0, bakit 0 to 1? Kasi ito yung boundaries ng problem natin. Okay, then you have your G of x minus x, x and x prime. Okay, and then your f is x prime. The x prime. Okay? Suppose yung f of x prime ay given yan. Nasa problem yan. Okay? Nasa right-hand side ng problem. Okay? And amazingly, kuwari, magsulat tayo ng random f of x prime. So let's try f of x prime is just sine of pi x. Okay? Sine of pi x. So this is x prime dapat. Diba? Okay, and then we evaluate the y. So this 0 to 1 ng G x prime sine. Okay? Sine pi x prime dx prime. Okay? What I can do is split the integral from 0 to x, okay, and then g. So yung kukunin ko ay yung mga x prime that are below x. Okay? X prime that are below X. Okay, so yung G plus yung kukunin ko. Tama? Okay. Kasi X prime that are below X. G plus sin pi X prime. Ay, mali. Plus minus, so that's minus. Kasi may minus sign. X to 1. And what's left is the other side, which are X prime values. X prime values that are above X. X prime values that are above X. So this guy. Kasi X prime above X. Okay? Okay? Okay, so we write that down. Zero to X. Ang G plus natin will be negative 1 times this times this. Okay? So, pasok ko na si negative 1 dito para maging X minus 1 siya. Ay, wala. Okay. X minus 1. Then X prime sine pi of X prime dx prime. And then X1. The other one should be X prime negative tapos 1 minus X. Baliktad. X lang dapat. Okay, negative X of X prime, 1 minus X prime. 1 minus X prime. Tama, di ba? Ito yun. Okay, let's check this guy. Okay, so, pasok ulit si negative sign para cute yung equations natin. Aesthetic. Okay. Papagod mag-physics. Ba't ba tayo nag-physics? Okay. Yan. X prime. Okay. Okay. Now, bahala na kayo sa buhay niyo kung paano integrate to, no? Pero madali lang naman yung integrate. Hindi ko na lang gagawin. Okay. So, this is, sulat ko lang yung left hand side para hindi tayo maligo, no? So, this is still y of x. Okay. Nothing has changed. Okay. Okay. When we do the first integral, okay, I can factor out negative x minus 1. Okay? And the integral should be x prime sine pi x prime dx prime. Okay? Factor out ko rin yung other side. That gives me x. And then x to 1. Ng x prime minus 1 sine pi of x prime dx prime. Okay, may tanong. So, saan galing yung sine pi? Yung sine pi x ay kasi hindi natin ito ma-explore, di ba? Kung walang example. So, example natin will be, yung right-hand side should be sine pi of x prime. Okay? So, kuwari, may problem tayo na balik tayo sa problem natin. Ay, sumobra. Okay. Ito kasi yung original natin, di ba? Ito yung original natin. Now, hindi natin ito ma-explore kung wala tayong given function f. Okay, so nagtatry tayo ngayon. Kasi, okay, kung F lang yan, tapos na tayo dito. Tapos na tayo. Tapos na tayo dito. Okay? Okay. So that's it. Nakuha na natin Green's function. Then you can solve for y by using the Green's function. Pasok mo dyan. Then pasok mo rin yung f of x prime. Okay. And okay, that's it. Tapos na tayo doon. Pero again, syempre hindi naman mangyayari sa exam na ganun. So yung f of x prime mo should be given. Kuha ba? Kung saan nanggaling? So, arbitrary example siya para maliwanagan tayo sa mga ginagawa natin in life. Okay? Kuha ba? Kuha. Okay. So, kuwari, pinapatanong sa'yo yung Green's function, tapos ka na dito, okay na. Nakuha mo ng Green's function, ayun na yung goal. Okay? Pero kunyari, pinapakuha sa'yo yung y, gamit yung specific given na f. Okay? Kailangan mo solve to. Pa-plug in mo yung g mo. Okay? Okay. So, ayan. Ang example natin will be, lagyan natin. Example. Okay. So, ayan. Kasi nakakalito, di ba? May dalawa kang Green's function, tas isa lang yun nandito. So, in-explore natin ngayon with a specific example. Okay? Okay. So, yan. In-split natin para magamit yung dalawa. Okay. Now, we're gonna integrate this whole thing. So, kayo na magbahala mag-integrate nito. Pero ang lalabas will be, hindi lumipat. Okay. Negative x minus 1. Ang lalabas dito will be pi squared, so denominator. Then, negative pi of x cosine pi x okay, kahit anong f of x po ba, sir? Ganun po yung Green's function niya. Or may rason din po bakit ginamit yung sin pi of x. Okay, kahit anong f of x yan, no? Kahit anong f of x yan. Okay? Okay. Kaya ganito yung y o ano natin. Kaya ganito yung y natin. Kasi ayun yung ginawa natin sa simula. Okay? Nag-set up tayo ng 3 equations. Okay. First equation, sinulat natin yung this guy. Okay? And then sinupose natin na y should be this and that the Green's function acted on yung nag-act yung linear operator sa kanya should be this. Okay. So I can actually write this down as, mali. Sige. Ano nangyari? Oh my God. What happened? Okay. I could actually write this. I could actually set up my equations. Going back here. Okay. I would actually set up my equation as negative to, plus positive yung task. Positive. Ito. And the same thing would happen. Okay? Okay? Pero syempre, para madali yung intuition natin, yung right-hand side, pinlog in ko na siya rekta dito. Okay? Para katabi na lang siya ng Green's function. So yung negative niya ito. Tapos yung negative niya nandito sa nilabas ko lang. Okay. So yung in general, y of x should be the integral of the Green's function times the right-hand side. Okay? Green's function times the right-hand side. Nilabas ko lang yung negative. Okay. So ang rason lang kung bakit wala yung mga drawing. Ang rason lang bakit naging sign, example natin bakit naging sign yung f. Kasi ito yung nasa libro ni Arken. Okay? So yung ko lang, pinattern ko lang yung example. Okay? So arbitrary to, pwedeng maging x squared yan or something. Okay? Okay, so going back, no? So lagay na natin yung mga integral. Okay. So going back, cosine, pag in-integrate mo yung mga integrals mo, should actually sine pi. It's actually this, and the second integral is actually, okay, pansinin nyo, no, si x prime nawala kasi pinlog-in mo na yung mga values na to. Okay? Yung iba dyan mag-zero out kasi maging sine pi, cosine pi, etc. So, yan na lang yung natitira. Try nyo na lang on yourselves. Okay? And then the integral that will result from this is pi squared pa rin ilalim of x minus 1 cosine pi x. Okay? And then plus, may sign minus sine pi of x. Okay. So pag in-integrate itong dalawang integral na ito, lalabas siya dito respectively. Okay? Okay, let's see kung may magka-cancel. Tinan niyo yung cosine. Okay? So ang factors ng cosine pi ay, yung cosine pi x ay negative pi x. Okay, negative x. May negative x sa kabila. Tapos may pi. Tapos may x minus 1. However, may extra negative yung kabila. So, yung mga cosine terms, mawawala. Okay? And then, we're left with sine. Okay? So, sine naman, check natin. Sine parehas, wala silang kasama. Ang titignan na lang natin ay this part. Okay? Tsaka yung negative 1 dito. So, this, in essence, this is positive x. So, positive x plus this guy is positive x minus x plus 1. So, I'm left with positive plus sine pi x all over pi squared. Okay, what a nice. Burahin ko na tayo. Ayun yung pabura. Nagloloko. Okay. Walang tinanggal ko lang yung plus. Okay. Okay. Now, na? Okay, this is your y. Nasolve na natin si y of x. Okay. So, nasolve natin yung ay magpasulat. Okay, ayaw niya magpasulat. Yan, masubura na siya. Okay. So yung y natin Na-solve na natin siya from na-solve natin itong equation na ito. Okay? And then, if we can complicate, oops, negative to. So, if we want to complicate the notation, squared 1x sine pi of x. Okay? So, that's it. Yung solution for this guy is this guy. So, actually, pwede siyang tignan ng ano, no? Tignan na kung magaling kayo mag-math. Madali siyang maisip yung sagot. Pero in-explore lang natin yung power ng Green's function. So, di ba mag-derivative mo to twice? Kunin mo yung derivative nito. Okay. Sin pi squared is actually derivative ng negative cosine pi x times pi over pi squared. And again, this is just negative sine pi x pi squared. Pi squared. That gives me the right-hand side. Okay? So, syempre, in the exam, actually, hindi ko pa alam bibigay sa inyo sa exam. No? Kasi hindi ako yung mag-handle ng questions nito. Ay, Sir Baguna yung mag-handle ng questions. Hindi ko pa alam kung paano yung bibigay niya. Pero 3D daw yung bibigay niya. Ay, nako. Hirap. Okay. So, ang essence nito ay to be solving much more complicated things. Okay. And then, kung makikita nyo sa ARF, binigay na yung mga forms ng Green's function. Green's function, no? In general. Okay? So, let's explore things sa three-dimensional. Okay? Or sa three-dimensional. The Green's function is actually okay. The Green's function, or R prime, in our notation, in general, is just negative 1 over 4 pi R prime. Okay? And kung iisipin nyo itong denominator, it looks complicated, but this is just actually the magnitude of your curly R. Okay? So this is just the curly R that we have. Okay. So that is the Green's function in 3D. Parang, sir, bakit parang ang dali niya? Okay. Ang mahirap dito kasi hindi to useful. Hindi to useful na. Ang expansion niya would be something like this. So i-expand natin yung denominator. Actually, nagagawa na natin ito sa multiple expansion. Okay? Ang expansion nito will be this guy. And then 2L plus 1, 4 pi, G of R prime. So ano yung G? We'll see in a moment. PL, then cosine theta. Okay. Okay, so note lang natin, theta here is angle between R prime. Okay? Okay. And then yung G, yung small g, should be written as something like this. So ito ay in general kasi given naman na yung Green's function for some systems. Nagsisolve lang tayo minsan kasi minsan weird yung system. 1 over 2 L plus 1 R raised to L, and then R prime raised to L plus 1. Okay. That is for R less than R prime. Okay. So I suppose natin isipin nyo ngayon si R prime, no? Parang shell. Okay. So within that shell, this is your equation. And it makes sense kasi kapag nasa origin ka, R is equal to 0, this whole thing doesn't blow up. Okay. So this whole thing cancels out, zeros out. Okay. The other side. Plus 1, R prime plus L, RL plus 1. Then this has to be greater than R. Now, pag inisip mo ngayon, if we extend R to infinity, this R, this doesn't blow up. Okay, good. This doesn't blow up. Okay? Okay. So, di ba ang equations natin usually ay this guy, V must be equal to negative rho over epsilon. So, V is actually the negative integral ng A to B. Kung gagayahin lang natin yung Green's function na prescription natin, rho over epsilon not d tau prime. Okay, so ito ay R prime, d tau prime. Okay, kapag pinlog in natin tong si, napansin nyo, ito. Green's function is 1 over, negative 1 over 4 pi. V is equal to negative AB, negative 1 over 4 pi, 1 over R, R prime. So, this is your usual thing, di ba? Okay. D tau prime. Okay. This is very familiar, di ba? Cancel out yung negative, 1 over 4 pi epsilon naught rho over curly R. Curly R to isipin niyo. Okay. Very familiar, di ba? And then, syempre, ang useful sa atin, yung pa-plug in mo to. Pa-plug in mo ngayon yung expansion. Pag pinlog in mo to ngayon dun sa this guy, makukuha natin yung multiple expansion. Siyempre, ito pipiliin mo, di ba? R greater than R prime. Kasi, yung far distances yung kukunin mo. Okay? Galing, di ba? So, sa electrostatics, madali lang kasi we are given simple things to work on. Okay? So, ang pinadagdag to ni Sir Baguni, kasi gusto niya kayo matuto ng hardcore shit in the... Sorry. Gusto niya kayo matuto ng ng things na helpful in the long run. Okay? So, itong si Green's function, lalabas siya sa buhay niyo kung mag-physics kayo, no? Okay. So, yung lang dito is simple steps lang. Okay? So, again, let's take a backtrack kung anong pinagdagawa natin. Okay? So, first, you understand your problem. Okay? This is the given problem for us with some arbitrary f na given din. Okay? Our goal is to find y. To find y, we suppose that we can write y in terms of the integral ng Green's function times the right-hand side. Carry? Okay, nating magulo pa. Then, you now suppose what the operator acting on G will be like. Okay, so we suppose that yung LG will be some Dirac delta function. Okay, so ito prescription to, no, na ganyan usually siya. So pag 3D nagiging nagiging cubic, no? So meron siyang x, y, z, etc. etc. Okay. So that kapag ginawa ko yung yung operator L ko to your supposed solution, magka-access sa G, may LG, you can plug this whole thing here, then you obtain the right-hand side. Okay. And then, with that, you can now proceed in solving your LG. Okay. Yung LG, that's this guy. Equals this guy. Okay. So, in doing so, kailangan mong i-expand ulit yung operator mo into differential things. And babasagin mo ngayon yung differential mo through integrals. Kasi si Dirac delta, useful lang siya kapag may integral ka. Dahil this guy. Okay? Okay, so ayan. So yung d squared ko, dx squared. Okay. Wait, lalag pa ako, sorry. Ayan. Okay, so si d squared ko, pwede siya matanggalan ng values. Okay. Tapos, integrate ko once para magamit natin yung integral no Dirac delta. The integral bounds ko will be around the x prime value para ito ay maging 1. Okay? Okay. And then, okay, we have this notation. And now we must find G prime. Okay? So, before that, paano kung makapunta ng G prime? Punta ka muna sa G. Si G mo, we suppose that it can be a two-factor. Okay, factor ng x and x prime. Very simple. Tapos, okay, so pwede niyang skip ng part na to. Pwede niyang sabihin na symmetric talaga to. So, dapat yung lalabas ay this guy. Okay. And then, from here, iisip ka ng values ng y mo, which could satisfy the boundary conditions. Okay. Now, again, we suppose that yung solutions mo from here should be reasonable. Okay? Okay. So, itong y1 of x, pwede kasi siya maging x to the 6 kasi masasolve naman na yung problem mo na kapag x is equal to 0, the whole thing is 0. Okay? But that doesn't sound right kasi ang sinasolve mo ay second derivative ng g dapat maglako. Okay? Okay. So, sinupose natin na ito yung mga solutions. Okay? And then, hanapin natin yung y and y prime. Then, now we can find yung constants ng a. Kasi si a, nahanap na natin si y, y1, y2. Para mabuo yung Green's function, kailangan mo yung constant, syempre. With that, solve na natin yung constants. Okay, na-solve natin yung constants. A. And now you can actually write your Green's function. Okay. To obtain the solution for y, you go back to your prescription kung ano yung ginawa mong setup. Ang ginawa natin setup is this. Okay. With the right-hand side, you just evaluate this equation, this integral, actually find your y. Okay. Para magamit mo sa dalawang value ng g, kailangan mo split siya. Okay. Okay, there is actually a nice thing here that's happening. Masyado madaling example natin na second derivative lang. When you can actually have something like, sige, sulat natin. Nagloloko pa. Ang bagal na internet pa. Wait lang, bagal ng internet ko. Okay. So, yung L mo can actually look like this. D squared dx squared plus d dx. Okay, this is more problematic. So, we have y, where based on function x. Okay. Anong po gusto kong maging nangyari? Okay, I suppose my y should be amazing. May limit pala itong ano. Sino pinagsusulatan ko? Okay, so pakanan na tayo ngayon. I suppose my y could be written as g x prime, and then the function on the right. Happening. Sorry guys, naglalag internet ko. Okay, dx prime. Okay, I suppose this guy. And then I go back to my operator. Suppose LG. Again, very similar to sa mga ginagawa natin. This is the direct Dirac delta, x prime. Okay, and now what's intriguing is how things work. Okay, here we have dalawang derivative. So, gawin natin. D squared, dx squared, g, x prime, then plus dx g x prime is be equal to Dirac delta. Oops, x prime. Okay. Now, I integrate usual thing with respect to x. So, that's x prime minus epsilon, x prime plus epsilon, dx squared, g. G na lang muna, no? Para hindi tayo mahirapan. Okay? Plus, anong pinapoint out ko? Tingnan natin. Naalaman niyo kung anong pinapoint out ko. Dx g must be joke dx prime dx joke lang dx. Okay. And then x prime and epsilon, x prime plus epsilon. This is your Dirac delta. Okay, very straightforward. Doing this integral gives me 1. This guy, g prime, ang lalabas dito, evaluated from x prime, epsilon, x prime, epsilon. Okay. Then, I add this thing. Tingnan nyo this thing. G must be evaluated. G na lang siya, di ba? G evaluated x prime, epsilon, x prime, as epsilon. Okay. Ang funny dito kasi, this is just 0. Okay, this is just 0. Yung g of x evaluated at x prime plus epsilon, x prime, must be equal, and the other side is x prime minus epsilon x prime. Okay, when we approach the limit, as epsilon approaches 0, this whole guy is just g of x prime g. Okay, normal pa rin naman. Okay, ang mangyayari kasi ay this guy is just equal to this guy. Okay? Ang kanina, ang g prime is not always equal. Okay? At boundaries. Okay? Okay. Not equal. Okay. So yung function small can be equal at some point. But at the third derivative at that point may not be equal. Okay? Okay? So mawawala tong second term. Okay, so mawawala tong second term and you'll be back to the thing that we solved earlier. Okay? So si A uh, at this configuration, ganun pa rin. Makikita nyo ito sa discussion ni Arken na sinulat niya kasi yung mga second derivative as in terms of some factor p para ma-account for yung mga factors niya dito and some other factor which is q. And makapansin niyo na pilang yung nagsusurvive. Okay? Pilang yung nagsusurvive whenever you do this process. Okay. So that's it. That's it for explore niyo yung mga things sa Green's function. Okay? So basically this is yung preliminary steps in doing so. Okay? Okay. So any questions, guys? Any questions? Sir, paano po yung 3D? Okay. Yung pag 3D, pinakita ko yung 3D form. Okay. So, ang 3D na form, nasan ba yan? Okay. Yung 3D na form will be, ang mangyayari is, same pa rin yung process. Ang magbabago lang is yung prescription mo ng y. Okay? So, yung y kapag 2D, xy, magkakaroon ka ng dalawang integral with respect to dx, dy. Okay? Okay? Tapos, yung operator of G mo should be dalawang yung prescription niya will be something like this. Okay? Pangit ng notation. Pero kasi di ba naalala niyo si cube of x, y, z. Ito pala. It's just x, y, and z. Okay? So, ganyan yung prescription na mangyayari. Okay? So, it might be a little bit confusing pa ngayon sa inyo. So, hinihintay ko kasi yung gusto ko i-pattern sana yung exam questions to this. Okay, kung anong gagawin para maliwanagan kayo. Kasi unfortunately, wala pang exam questions. Okay? So, ang ginawa ko na lang is yung simplest example. Kasi yung basically pag in-elevate mo to other higher dimensions, the same lang yung mangyayari. Ang kailangan nyo mag-gets talaga fully is itong one-dimensional example. Okay? Pero in essence, sabi ko nga, yung 3D representation ng Green's function is already this. It's already done. Okay? And then you just expand this to this. Okay? Ito yung multiple expansion na ginawa natin. Okay? Tapos yung PL, yung Legendre polynomial. Okay? So, ang problema talaga is paano yung mga operator L that are defined weirdly. Okay? So, kapag yung operator mo, Laplacian, you can easily solve it. And this is it, no? Ayan yun. However, some definition of given, I mean, given sa atin, minsan they're like this, or they're like this. Okay. And sometimes they're like this. So, more complicated systems to. So, probably hindi lalabas, no? Dahil 130 lang to. Kung magma-masters kayo, makaka-encounter kayo ng mas mahirap. So, Helmholtz yung tawag dito sa isa dito. Nakalimutan ko which one is. Okay? So, ang first thing to do kung gusto niyo practicein muna is to try linear problems muna. Okay? Linear problems ka lang muna. And you want to explore. So, ayun. Okay, ang gagawin kong question sa exam will be on chapter 2. Si Sir Baguna sa chapter 3. Chapter 2, nafe-feel kong magbigay ng capacitor problem. Okay? Okay. So, good luck. So, anything else? Any question pa? Any question pa? Sige, magtanong na lang kayo. So, medyo nakakalito talaga tong Green's function, no? Kasi may dedicated na subject kami dito. Or at least 2 weeks of 113. Yung Green's function namin dati. I mean, nung nag-masters ako. Okay, kaya medyo nakakalito siya kung okay lang yan kung nalilito pa kayo. You just try it by yourself, by your hands, para ma-practice mo. Okay, anything else? Kung wala na, sige, meron ganyang sir sa MedFi. Yes, feel ko meron. Okay, feel ko meron. Dapat. Kasi this is hindi kasi this is a way of solving things. Okay, so in Green's function is a way of solving things. So dapat din siya kinakatakutan. Parang it's your friend, no? To solve things. And usually, feel ko, pag more of application ka na sa MedFi, mawawala na to kasi more of experimental na. But if you're trying to do theoretical na MedFi, this might be of help to you. Okay? So, anything else? Anything else? Okay, kung wala na, sige, stop. Anong recording ka na?